morning, everybody. Right now we're finishing up section 6, dealing with rational equations. And we actually have a rational equation in this word problem, even though you can't see it. I need you to understand Morgan is going to drive her car 30 kilometers to the train station. So let's say she starts right here. We'll call that point A. And then she travels to the train station. That is how far away?
30 kilometers.
30 kilometers. All right, 30 kilometers. I'm going to say, this is your home. This is the train station. Train station. All right, and then she boards a train to complete her trip. The total trip is 120 kilometers. So we'll put over here, we'll put C, and we'll say C represents her final destination. Not the horror movie where everybody dies. All right, but just her place where she finally comes to an end. You what?
I love this movie.
You love it? I don't like it. The very first one was okay, but then it kind of got redundant. It was like, you already knew it was like, okay. The first one was like, oh, kind of interesting. But like Final Destination, like 5, I don't know how many.
They're about to die.
Like, you know, this whole movie, they're about to die.
Don't get
But not right now. Not right now. Okay? She's gone 30 kilometers, and then I want you guys to write in 90 kilometers here, because from here all the way over there, that's, by the way, we're still recording, just so you know. It's still recording, so you can hold off on conversations. All right, so the total trip was 120 kilometers. All right, so now you have a little picture of what's going on. It's always good to draw pictures to help represent the problem, to help your brain understand what the heck's going on. Got that down?
I drew it in like perfect.
Awesome. Perfect. Now, it says the total, the average speed of the train is 20 kilometers faster than that of the car. So let's see. The car, let's say the car travels X kilometers an hour. What will the speed of the train equal if the car is X? What's the speed of the train? X plus 20. We'll put X plus 20. That's correct, Miranda. At what speed must she drive her car if the total time for the trip is less than 2.5 hours? So it has to be less than 2.5 hours. Okay, so we need to go back to our formulas that we know are true. And distance is always equal to rate times time. All right? Now, there are 2 times we have to worry about. Time 1 and time 2 have to be less than 2.5 hours. Now, time 1 represents the time that she was in her car. And time 2 represents the time that she was on the train. But together, these times have to be what? They have to be less than 2.5 hours. So if we have the formula, E equals R times T, we need to solve for what letter?
T.
T is correct. We need to solve for T because we're dealing with time. T1 is time. Okay? So if I wanted to solve for T, I would have to divide this side by an R and this side by an R, and distance divided by a rate is equal to your time. I know. It's complicated stuff. All right. By the way, do we know how far she traveled in her car?
Go ahead.
How far?
120 kilometers.
I'm sorry, that's not correct.
Okay, 220.
Nope, still not.
130.
Nope. 30 is correct. In the car, she traveled 30 kilometers in the car. By the way, do we know the rate of her speed in the car? We do? Okay, what is it?
No, we don't.
X is correct. X is correct. We don't know the speed, so we said it was X kilometers per hour. Bless you. Now, Do we know the distance she traveled by train?
Yes.
90 is correct, once again. I appreciate those of you who are watching up here going, oh, that's what she did by car, that's what she did by train. So that's the car trip. That's the train trip. Okay? So we put 90 kilometers. Do we know the speed of the train?
Yeah,
Or
X plus
20.
20.
Yeah. X plus 20.
X plus 20. Very good. Or 20 plus X. And we're going to set this less than 2.5. Now, by the way, on the front page, everything was already set up for you, like how to do rational equations. All the problems were set up. In the word problem, what did we have to do? We had to set up our own rational, in this particular case, inequality. Okay? But what I want you to do now is I want you to take this whole thing right here. Take that whole thing, and you're going to multiply it by the least common multiple between an x and an x plus 20, which is x times x plus 20. So what I'm going to do right now, I'm going to take all of that, all of this, and I'm going to multiply it to this guy, and to this guy. So right now, I'm going to pause the video. I'm going to write everything out, and then if you're watching the video, you can pause it and write everything out. All right, everything has now been distributed. Notice, every single expression has x times x plus 20 in the numerator. And the reason we did that was so that these x's would cancel out. So these x plus 20s would cancel out. And now we have a 1 in the denominator and not a variable in the denominator. Okay? So what do we have left? We have a 30 times an x plus 20. Here we have a 90 times an x. And here, it's slightly more difficult, I'm going to say we have 2.5 times an x times an x plus 20. And notice, I'm not going to put over 1 now, because that's the reason why we had to do that, cancel all those variables out. So write this right here on your paper, and then we'll go from here. Here's our inequality sign that we have to worry about. Okay. All right, the next thing I want you to notice, that we need to distribute. And over here, we also need to distribute. So 30 times x is 30x. 30 times 20 gets us 600. Plus 90x is less than 2.5 x squared plus 50x. Because 2.5x times 20 is 50x. Automatically when we do this, everybody, you should notice that we're dealing with a quadratic equation, which means we need to get all of the quadratics on equal to 0, all right? Or greater than or less than 0, depending on if it's inequality. So right here, what can we combine over here on this side? We can combine the 30x and the 90x, and that gives us 120x plus 600 is less than 2.5x squared plus 50x. Since we already have positive x squareds over here, my suggestion, you don't have to do this, but it makes it a lot easier if you do, is I would take away 120x from both sides and take away 600 from both sides. So you're left with 0 is less than 2.5 x squared minus 70x minus 600.
So is that the answer?
That is not the answer, but that is the quadratic equation that you need to use, and you can use the quadratic formula to solve it. But what I'd like you to do before you do that, to make it easier, I don't know if you guys know this, but all of these right here are divisible by 2.5. So in the calculator right now, we have 0 is less than x squared. What's 70 divided by 28 minus 28x. And what's 600 divided by 2.5?
300.
240. 40. So here we have x squared minus 28x minus 240 is greater than 0. By the way, my a value is equal to 1. My b value is equal to a negative 28. And my c value is equal to negative 240. And you're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And always start, my suggestion, always start by finding this discriminant first. Okay? So use these numbers to plug in, find the discriminant first, and solve your equation. You're going to get a positive answer, you're going to get a negative answer. Disregard the negative answer. That's an extraneous solution. It will not work. Find the positive answer. Remember, the first thing I told you to find was the discriminant. So if you plugged everything in correctly for the discriminant right here, you should have gotten 1744 for the discriminant. Now, if I use the quadratic formula, that's negative times a negative 28 plus or minus the square root of 1744 all over 2 times a, and 2 times 1 is just a 2. So your answer is 28 plus or minus the square root of 1744 all over 2. But I told you, only get the positive answer. All right? Which means we're going to use the plus. So we're going to say 28 plus the square root of 1744, which is not a perfect square, all over 2. If you type this into the calculator, by the way, if you ever want to get the fraction wrong, that's alpha y equals enter. All right? If you type that in, you will get the decimal 34.88, which means her x value, all right, right here, needs to be what? Needs to be greater than 34.9 kilometers an hour, which means that's the speed of her car. Speed of car. If she drives faster than 34.9 kilometers an hour, then the time will be what? Less than 2.5 hours. That's your final answer. If you get this wrong, it's your own fault.